Tech AV welcomes you to another program in the Seals and Gaskets series, which has been produced in association with John Crane Pty Limited, leading manufacturers of mechanical seals and compression packing material. In this program, you are going to learn about the subject of GLAND packing. We shall first overview the need and principles of GLAND packings, and then describe and demonstrate the procedure for replacement and adjustment of such packings in typical applications. Let's begin then as we learn the principles of GLAND packings. As you learned in the program on the rotary shaft seals, we require a method of preventing lubricating fluid from leaking out past a rotating shaft. However, in equipment such as pumps, compressors, mixers and the like, a different method of shaft sealing is necessary. The oldest but still widely used method is called a GLAND, whereby the shaft is surrounded and sealed by a series of rings called packings. The packings are contained within a hollow casing called the stuffing box. A GLAND follower holds and compresses the packing rings to the desired compression rate. For this reason, packing ring material is also referred to as compression packing. The materials mostly used to produce packings consist of yarns or fibers made from materials such as cotton, flax, asbestos, and synthetic fibers. No matter what material is used, it must be able to be compressed in such a way that a slight tightening effect against the rotating shaft is achieved. In pump applications, it is necessary for the packings to be well lubricated. This tends to result in leakage, which is a normal situation. However, in applications such as valve stem sealing, a GLAND packing will actually prevent leakage. From a maintenance point of view, GLAND packings require fairly frequent attention, and in the case of pumps, a poorly adjusted GLAND could result in expensive pump damage. Let's see why. The rotating pump shaft is effectively being supported by the packing rings, which act like a bushing. As with any bearing surface, some form of lubrication is necessary to prevent frictional damage. A packing is lubricated by allowing fluid, often the actual fluid in the pump system, to enter between the packing and the shaft surface. The only way to be sure that the GLAND is receiving lubrication is to see visually a leakage past the packing. Tightening the GLAND follower produces a degree of squashing of the packing rings onto the shaft. Over-tightening, the commonest problem, reduces the space required for lubrication to flow, and the result is a dry seal. The seal then overheats, destroying itself and the pump shaft in the process. Achieving the correct leak rate, and thus preventing costly repair work, is to a large degree dependent upon correct selection of packing material and good preventative maintenance. Let's discuss packing materials first. With rapid industrial advances over the last 50 years or so, more and more fluid types are being developed, pumped, mixed and treated in a variety of systems. The actual selection of a suitable material depends upon 5 main conditions, namely, the type and nature of product or fluid in the system itself, the rotational speed of the shaft being sealed, the diameter of the shaft, pressure within the system, and the temperature within the system. As none of the conditions is controllable by maintenance personnel, the selection of suitable packing material can be made only by A. Following the equipment manufacturer's specifications, B. By consulting your supervisor or engineer, and C. By consulting with your local supplier or manufacturer of packing material. If you are not sure about which packing type to use, don't guess. Make every effort to find out. Most manufacturers offer helpful catalogs to assist you in making a correct choice. The usual way to purchase packing material is on rolls, which we refer to as length form. Certain packings obtained from original equipment suppliers may be in die form, which means it's cut and formed ready to fit. For purposes of demonstration, we shall be using length-formed packing. This we shall do after the break.